Hello, my name is Mark Billinghurst and I'd like to talk to you today about SecondSight, a framework for cross-device augmented reality interfaces. This is the work done by Carolin, Reichherzer, Jack Fraser, Damien, Rompapas and myself from the University of South Australia. Hello, my name So the motivation for this work is looking at how we can develop interaction with head-mount displays, augmented reality head-mount displays. This is traditionally very difficult to do, but current augmented reality head-mount displays can be connected to mobile phones, and so now we have a new interaction methods that can be used by using the mobile phones. So the key questions are, how can we use a head-mount display and mobile phone hybrid interface to support new types of interaction? And what is the effect of different fields of view of the head-mount display on the user interaction? To explore this, we want to develop a range of different prototypes, and in particular we want to use AR to be able to extend the display beyond the physical phone screen. We want to simulate different types of head-mounted display fields of view. We want to support multiple interaction modes using a touchscreen or gestures or head pose. And we also want to place virtual AR windows either attached to the real phone or attached in the world. So we developed the software framework we call SecondSight, and this is a framework for rapidly prototyping these types of hybrid AR head-mount display phone interfaces. It supports multiple modules, and each of which provide the functionality that we need. So for example, we have a head-mount display module that allows us to do hand tracking and head tracking and place virtual information in the world space or the device space. We have a smartphone client module that allows us to overlay information onto the smartphone screen, and a server module that connects the networks of the phone and the PC and the head-mount display together. This is implemented using a Meta 2 see-through head-mount display that has 82-degree field of view and hand tracking. The Meta 2 is connected to a Intel PC and using the Samsung Galaxy S8 phone. We also use the OptiTrack motion capture system that could track the phone and the head-mount display, and Unity and the mirror networking API to connect the two together. So this is a video showing the interaction techniques we support. We support head pose interaction, where the person can look at a virtual window and tap on the phone screen to select the window and move it around using the head gaze. We also support gesture interaction, where they can reach out and grab virtual windows with their hands and pull them around as well. Hello, my name is Mark Billinghurst and I'd like to talk to you today about SecondSight, a framework for cross. In terms of interface modes, we could have device-fixed virtual windows that appear fixed onto the phone, so as we move the real phone around, the virtual windows appear attached to it. We can also have world-fixed windows that are dropped in space, and as we move our head viewpoint around, they appear fixed in space relative to the real world. We can also simulate different fields of view. So because we have a physical field of view of 82 degrees, it means we can simulate anything up to 82 degrees field of view. And so this shows you the Unity interface that allows us to make smaller or larger simulated fields of view. So to evaluate the framework, we built a simple application and we conducted a pilot study to explore the effects of AR head-mount field of view. And we did a data visualization task where we had to look through health data and compare their heart rate on different days. And we used 4 simulated fields of view, 15 degrees, 30 degrees, 55 degrees and 82 degrees. People provided subjective feedback on a 5-point Likert scale, where 5 was very easy and how easy it was to use the system, and 1 was very difficult. We also observed the virtual window placement, and we had the condition rankings as well. So what we found was, not surprisingly, but users felt that the wider field of view was easiest to use. Most users also had a similar window placement. You can see the window placement there, where they tend to place windows above and to the left and right of the real phone. And we also got useful feedback on how to improve the user interface. So the software framework can be used to develop a number of sample applications. Here's another one. This is a map application where we can tap on the map on the phone screen and see virtual windows popping out, appearing around the phone to give us more information about those locations. Here's a puzzle application we built where you could drag and drop virtual puzzle pieces and use hand gestures or head gaze to arrange them in space. But there are many other possible applications that we built with a simple framework. So just in conclusion, we've developed a software framework that allows us to quickly build hybrid user interfaces that combine input on the phone and input and head-mount display viewing. This makes it very easy to build these hybrid interfaces, but there's a lot of work we can do in the future. We'd like to run a full user study, and we'd also like to explore new input modes such as speech and eye tracking. So if you have any questions, please email Carolin at this email address or visit our lab at the website below. I'll read the paper for more information. Thank you very much for your time.